Part A, express square root 6 cosine theta plus 3 sine theta in the form r cos theta minus alpha. That is the auxiliary angle form. R must be positive and alpha must be in between 0 and 90 degrees. So first quadrant angle. We need to find the exact value of R, and alpha must be correct to 2 decimal places. We expand cos of theta minus alpha using the compound angle formula. So that will give us cos theta cos alpha plus sine theta sine alpha, which can be written as r cos theta cos alpha plus r sine theta sine alpha. We now equate the coefficient of cos theta. We have r cos alpha equals square root 6, and equating the coefficient of sine theta, we have r sine alpha equals 3. We have equation number 1 and equation number 2, which we use to find the values of r and alpha. The sum of squares of equation number 1 and equation number 2 is r squared cos square alpha plus r squared sine square alpha equals 6 plus the square of 3, which is a 9. And when we factor out r squared, we have cos square alpha plus sine square alpha equals 15. From the fundamental identity of trigonometry, cos square plus sine square is 1, so that r square is 15. And since r is positive, it is the positive square root of 15. To find the value of alpha, we can divide equation number 2 by equation number 1. We have r sine alpha divided by r cos alpha. So that is sine alpha over cos alpha equals 3 over square root of 6. Sine over cos is tangent. Tangent alpha is 3 over square root of 6. And since alpha is in the first quadrant, we just find the inverse tangent of 3 over square root 6. Alpha is in between 0 and 90 degrees, so make sure that your calculator is in degree mode. Then alpha is 50.77 degrees, correct to 2 decimal places. Part B, we need to solve the given equation. Square root 6 cos x over 3. So for part B here, we have square root 6 cos x over 3 plus 3 sine x over 3 equals 2.5. This is similar to square root 6 cos theta plus 3 sine theta. From part A, we know that square root 6 cos theta plus 3 sine theta can be written in the auxiliary angle form, where r is square root of 15, and we have cos of theta minus alpha, which is 50.77 degrees. Compare the left side here to this left side. They are exactly the same, with theta being replaced with x over 3. So we can let theta be x over 3. And then we have the left part, so that square root of 15 cos theta now is replaced with x over 3 minus 50.77 degrees. This is 2.5 now. From here, we need to solve for x in between 0 and 360 degrees. So we divide throughout by square root of 15. We have cos x over 3 minus 50.77 degrees. That is 2.5 over square root of 15. Cos is positive, so your answer, this angle here, the whole angle x over 3 minus 50.77 is either in quadrant 1 or quadrant 4. We need to find beta first. That is inverse cosine of 2.5 over square root of 15. Now from your calculator in degree mode, you should have a value of 49.797 degrees. Then x over 3 minus 50.77 degrees. This is an angle in the first quadrant, which is 49.797 degrees, and also an angle in the fourth quadrant. We have 360 degrees minus 49.797 degrees. That is 49.797 and also 310.203 degrees. To find the value of x, you need to isolate x over 3 first, so that x over 3 is 49.797 plus 50.77 degrees, and we do the same for the second angle, plus 50.77 degrees. So that will give us 100.567 and 360.973 degrees. Now this angle is fine. It is within the range from 0 to 360, even when we multiply by 3. That is going to exceed 360 degrees. So we have to bring it down, go back one revolution. This is going to end up 360.973 degrees, subtract 360 degrees. And that would be 0.973 degrees. So x is 3 times 100.567 degrees, or 3 times 0.973 degrees. That is 301.70 and 2.92 degrees. These values of x lie in between 0 and 360 degrees. So that works. So be careful with this part here.